Hi everyone, we're from T-Mobile. My name's James Webb. This is my peer, Brendan A. We have been running together for a few years now, so we'd like to do these things together. He graciously hopped on at the last minute to be a co-presenter. So this story is not just about Kubernetes, it's more a container story. It's about what we've been doing at T-Mobile for the past couple of years and successes we've had and what led up to our decision to use Kubernetes and kind of how we made the choices to deploy what we deployed, how we leveraged our prior successes using Cloud Foundry, which we'll get to, and where we're going. So it's less technical, more of a journey story. So who we are. So we are T-Mobile Platform Engineering. Brendan and I and another product manager started the team in mid-2016. The goal was to bring Cloud Foundry to the enterprise. Basically starting from scratch. We had some hardware, we had a couple of customers, prospective customers, and the goal was take this product and make it a thing at T-Mobile.
In very short timelines as well.
In very short timelines.
Yeah, 8 to 12 weeks or so to launch for production with starting from scratch.
Yep. And short timelines is why it was one of the main reasons we chose a product provided by a vendor. We wanted to be able to hit the ground running and deploy immediately and use expertise that already existed that we did not have. So as you'll see later, the platform was wildly successful. We're now a team of 25, and we support IaaS, CaaS, and PaaS platforms. Our team, most of which is sitting out in the audience.
Hopefully nothing breaks right now.
Have a broad background, infrastructure engineers, system administrators, developers, platform admins, product managers, and we've also become customer success engineers. So it's not just enough to run a platform for your customer, you also have to engage the customer and make sure they're successful. We had trouble finding people to staff the team with. Our initial thoughts were, we'll go find people who know Cloud Foundry. Well, those people don't really exist. Yeah. So you have to go and we found people who were familiar with the technical technology stack we were using and who had the aptitude and attitude to succeed. And we found that has been a much, much better indicator of success on our team versus going out and hiring somebody that really knows the space but doesn't fit into the team culture. So
in general, we found if you know Cloud Foundry or you know Kubernetes, you're already employed. And pretty much every company hiring for those spots, they're always hiring for those spots because they can't find enough people. So you'll see a lot of people moving around from company to company as they try to reinvent their same success over and over, which they can usually do depending on where they go.
Yep. We ask our engineers not to put Cloud Foundry on their LinkedIn because that usually gets them job requests right away.
Great way to get spammed.
Yep. So we are part of a larger organization supporting all on-premise IT infrastructure for T-Mobile. So there's two ITs within T-Mobile. There's the IT that supports the cellular network, and then there's the IT that supports what's more like a classic IT. So we're on this side, not the cellular network side. What we manage. So we manage right now 3 main offerings. Cloud Foundry. We have grown from a single foundation hosting about 300 to 400 apps to 12 foundations hosting 3,400 application instances. Roughly 40% of that's production, 60% is non-production. We take in our production foundation roughly 300 million production transactions a day. It's kind of hard to, it's an interesting metric. The foundations take a lot more traffic than that, but a lot of that traffic is health checks and self-referential stuff.
Service registry calls, things like that.
Yeah, so it's hard for us to, as the platform team, it's hard for us to isolate what's a production transaction versus what's an overhead transaction. But we reached out to some customers and some of our larger customers and found that 300 million is a pretty reasonable number. It's probably a little higher than that, but that was a good guess.
Yeah, in terms of total traffic, it's probably a little more than double that. We see about 600, 700 million transactions a day coming through the entire routing layer of the platform. But like James said, there's a lot of hairpin traffic leaves the foundation, hits the service registry back in the foundation, or hits something else inside. Health check traffic, things like that, we don't consider to be a real business transaction.
We also have some data services associated with the platform that are accessible by service broker. So some of our customers subscribe to our MySQL, RabbitMQ, Gemfire, Redis services. And we we don't manage those services as experts on Redis, experts on RabbitMQ, but they are available. So you can subscribe to it, but then it's self-managed past that. We have an on-prem Kubernetes offering now. We have several flavors of it right now, 24 clusters, mix of various technologies, PKS, some open source, some older stuff that's from other vendors that we won't mention. We have live traffic going through our clusters now. We don't have so when I wrote this abstract, we thought we'd have probably about 5 to 6 more times traffic going through the clusters as we do today. But that's a lesson learned. Reality, bureaucracy sometimes slows things down. But we do have live traffic going through, and we're taking about 1 million production transactions a day through our largest clusters now, and we have teams that are actually actively ramping that up, and within the next 2 weeks, this should double or triple. We also are huge fans of BOSH. We use it for a ton of our own internal needs, and we also offer it to some of the customers we work more directly with to offer basically data services managed through BOSH, so that they don't have and the primary use case there is Rabbit. We didn't want them to become noisy neighbors on the Cloud Foundry brokered Rabbit instances, so we set up BOSH supplied instances for them to work with. It's been working great.
By a quick show of hands, have most of you even heard of BOSH? Anybody know BOSH? Okay, a handful, good. More than I expected. All right.
And then I'll turn over to Brendan here.
Yeah, so we were kind of, the reason for PaaS in the first place, we were in a situation where we as a business could not deliver business needs fast enough. It took us on average 7 months and 72 steps to get a single line of new code to production. That is a long time. You think about adapting to your competitors, to market change, to the whims of a somewhat eccentric CEO, and it's hard for us to keep up and deliver things fast enough. This got us into a bad situation more than once, where we had to outsource services to other companies, which then more or less held us hostage, and we could not then move away from them when we needed to. So we had this problem where we could not move fast enough. We had really no options. We could give somebody a server in less than a day or so, hopefully 10 or 15 minutes. But once you had that, you still had to deal with load balancers, DNS records, firewall rules, all these things before you could even put your application on top of it and do all your extensive manual testing and integration and deployments, config management, patching. It was just very laborious, very painful, and it really is zero value add work. So we decided we needed to go towards a PaaS that would make this stuff easier for all of our developers. So what used to take us 7 months and 72 steps can now be done same day. People find and fix bugs and patch them same day, going through dev, about 10 or 15 test environments and going on to production. This is all daytime work, zero downtime. I think 90–95% of deployments in PaaS happen daytime with zero impact to our end customers. So that's been just a huge benefit for us. We can now adapt much more quickly to change. Also, the general transition from monoliths to microservices has been enormous benefit. It used to be extensive regression testing on the 1,000 functions in some of these middleware services, and now they have a few functions inside of a small microservice. They're able to move much more quickly, much more reliably, test in a much smaller scope, and they're able to do these changes with zero downtime and, more importantly, zero incidents caused by change. I think in the 2.5 years we've been doing this, we haven't seen a single Sev1 or P1 incident actually caused by change. In terms of deployment agility, because we're able to move so much more quickly, they're able to make smaller, more incremental changes, a much more agile approach instead of the long-term 2 or 3 month waterfall process where you're trying to hit a moving target that you're probably going to miss at the end. So you're going to deliver something that's no longer even meeting needs you started out with once you finally get it to production. Again, the daytime changes, we can now do canary testing in a much more small and reliable way. We don't have to worry about, we cut these 50 stores over to this one instance of an app that's running. It can now be, 5% of all traffic now goes to, version 2 instead of version 1. And we're able to test these things much more reliably. We used to have deployment weekends. We still do for some apps that aren't running in PaaS, where it would be 60, 70, 80, 100 developers in a room for a whole weekend, drinking Red Bull, eating sandwiches, because every app being pushed is all tightly coupled. They must succeed. And when an app deployment must succeed, you're shooting from the hip, you're making changes last minute, you're touching production in ways that you probably shouldn't be, and you never make those changes back down from prod to all your sub-prod environments. So next time around, you're in an even worse state than you were before. Beyond that, just the inefficiency of having developers and operations team worry about the state of these very stateful servers, the pets they've had around for 3 or 4 years that all have names and very important meaning to them. We had teams that had maintenance windows from 10 p.m. to 4 a.m. 5 or 6 nights a week. And they worked those maintenance windows 10 p.m. to 4 a.m. 5 or 6 nights a week. They did patching, they did configuration management, they did application deployments. They had whole silos of hardware where they would have an identical stack, a few racks over, and they would say, this stack right here is no longer active tonight. We're going to do all our work there. We'll eventually cut back over to it when we have our next maintenance window tomorrow night. With the benefits we get from PaaS and containerization, these developers and DevOps teams can now sleep. They can spend time with their family. They can focus on operating their apps in a way that makes them more efficient instead of just the endless, monotonous, zero value added work they were doing previously. And one of the biggest benefits we've seen from a very hard cost perspective is just consolidation of workloads. Some of our most important middleware applications, we had about 2,000 physical servers running these loads before. Very painful to operate. We had a lot of redundancy built in there. We're now running those same workloads on less than 150 physical servers, along with everything else running in PaaS. So incredible consolidation here. We have much higher utilization on this physical hardware, and we're able to decommission all those servers that required maintenance and support contracts and all the patching that went along with that. Next slide.
Yep. Brendan's practiced that talk before.
Similar themes to previous talks. So if PaaS worked so great, why are we here at KubeCon talking about Kubernetes and why we're going that route? So PaaS is great if you have a workload that fits in PaaS. If you don't, you're going to have a pretty bad time. We had some applications that were vendor-delivered containers. It's much more popular now than it was even 3 or 4 years ago, where they're not giving you an RPM or deb file. They're saying, here's our container, just run it and it'll work just fine. That works fine for some containers, but other ones, we have in particular one that's an order management system. It has a local cache that has to warm up every time it starts out. Then it has to offer out a RMI port that allows it to receive updates to that cache anytime there's updates made. So in the PaaS world, this is a bit non-standard. You have what should be persistent storage underneath that we're not offering, and then you have this kind of non-standard TCP routing instead of standard HTTP routing. So we had candidates like that we said, this will never work properly in Cloud Foundry, and somehow they got it working. They had huge agility gains, just like we saw with other apps moving in there, so they wanted to keep on running in this environment. But we found those as we did upgrades to our PaaS, we didn't have problems with the native apps that ran with the Cloud Foundry build packs. We had a problem with these Docker apps. Things would change in the Docker runtime they're using, other security standards that were tightened down, and these apps running in Docker would always be the ones that caused us problems. In addition, because of the way they had TCP routing for some of these apps, it wasn't really a great use case to have this almost a pet running inside a container from the management perspective. So they had to scale out in a very non-standard way that led them to they couldn't be as agile as they wanted to be. So this kind of bore the need for a CAS inside T-Mobile instead of just a standard PaaS, where instead of having this strictly opinionated approach, they could run a much more generic container in Kubernetes, get best-in-class orchestration, and be able to really adapt to the needs they had, be able to deliver services from vendors or from Docker Hub, whatever they want to do. They can run these things much more easily, and most importantly, with persistent storage. There were some patterns for persistent storage in PaaS, but we didn't want to adapt those because it's based around NFS, and it wasn't really a scalable pattern long-term for us that we could properly secure. And then, last one was just the platform orchestration, the ability to have, multiple apps or deployments as part of a stateful set that are able to have interdependencies. If something crashes, it will bring up something else. We didn't really have that ability because we had much more independent instances in PaaS that, didn't really fit the needs of some of these people that had much more complex stacks where they had interdependencies.
And then the other thing is we actually had a lot of teams that were that did not want to move or didn't think that their apps could move to Cloud Foundry. But also, when they called the infrastructure team and said, do you guys have a standard Docker offering? We didn't. So what they would do is go provision a VM and basically run their own Docker, right? So we have this shadow Docker, infrastructure that's proliferated through the enterprise, and we know the risks. There's a lot of risks associated with that. So we're trying to get that centralized and clean all that up, and by having a standard offering. So.
In many cases, we saw teams would take their existing application servers, wipe them clean, just install base OS and Docker, and use that purely as a delivery mechanism because they get enormous benefit from doing that. But in terms of long-term scalability, stability, they're still tied to that one IP address, still tied to the same firewall problems they had previously. So it's better, but it's not really revolutionarily better. So they wanted to have something better for actually orchestrating the containers instead of just running them.
Why on-prem? We get this question a lot. There's cloud providers that offer fantastic managed Kubernetes services. Why would you go through the effort to build it on-prem? Well, there is a lot of truth to the data center, to data gravity, and I call it data center gravity because there's a lot of other issues, not just data, right? So data is the first obvious one, right? We have a massive amount, petabytes of storage of data local to our data center. If we try and move that in and out of the cloud, right, that's a huge cost, right? And not just a huge cost in terms of money, but also a huge cost in terms of latency, effort. So we want to keep an app layer very close to what our systems of record are in the data center. What's the future of that? Who knows? But this is where we are right now. Network. Latency matters, right? For a lot of our middleware apps, they are very latency sensitive. We have certain SLAs. We try and meet with retail stores, call centers, and the web, so we want to make sure that we keep that as low as possible. There's also partners that terminate in data centers, so there's a lot of other network concerns that really factor into running on-prem as well. Security. All our security controls are written, or most of our security controls are written for on-prem. So when an app team wants to do something, they know how to do it on-prem. When they go to the cloud, it's a new discovery process, and it's completely doable, but it's a lot of extra overhead for those teams to move out there. Organizational, right? Again, going to the public cloud, not every team has some public cloud expertise. We have an excellent public cloud team. They do a great job of onboarding customers, but there's still a certain overhead that teams have to accept if they want to go out to the public cloud in a lot of cases. There's also a lot of our compliance documents in terms of SOX and other things are written around on-prem processes. So that's not even a on-prem or a cloud problem. That's actually a cloud native problem because it introduces a whole new class of systems that our compliance documentation doesn't really have terms or ways to deal with. So we're going through enough of that. Cost is another strong factor. A lot of the cloud is about velocity. We have data centers. If we can execute, there are huge savings to us deploying on-prem, right? It's not for every service, but for just like pure raw hardware capacity, memory, storage. It's actually a big cost savings to stay on-prem in a lot of ways. And then cost modeling, right? On-prem tends to be CapEx. Off-prem tends to be OpEx, right? So not everyone's adjusted to how those two things play out. Another thing is we want to own our own destiny, right? When we go to the public cloud, we're kind of beholden to certain things. Being on-prem gives us a lot more control. We do have a public cloud team. I see some of them out in the crowd. We love them. So they have their own K service and a lot of other things. So it's been a great partnership, and we've been converging with them to figure out what's our common offering going to be, and how do we help each other direct customers to the right places.
Yeah, it's very important from our standpoint that when teams move between on-premise and cloud providers, they don't have to learn a whole new set of workflows or API calls. So using Kubernetes as that abstraction, kubecontrol or the Kubernetes API is what you have to learn. You don't have to learn AWS versus Azure versus GCP. You can focus on that common abstraction and move much more quickly between on-premise and cloud providers.
So when late 2017, early 2018, we started coming up with what are our requirements for a platform, right? So the platform team, a common checklist, right? We need to be highly available at every level. We need automated deployment. That was a huge lesson learned on the Cloud Foundry side. Is everything we installed to start with, we installed by hand, right? And now someone else takes care of it, and it's not easy, and they're automating the mound of tech debt we left behind. Thank you guys. But on the CAS side, we wanted to start with automate everything we possibly can, not just control plane, but cluster builds. No downtime lifecycle management. So one of the huge advantages, again, of the Cloud Foundry side is that we can patch and keep the environment up to date without our customers knowing. So we want the same ability on the Kate side, because that's actually huge value to customers as well. Lets them focus on app development and supporting their application, not on keeping OSs patched or keeping versions of various tools up to date. LDAP integration, API configurability, and automated ops. So that's kind of our high-level list of what we had requirements. We talked with some teams and gathered their requirements as well, some application teams. They wanted to have a native K8s experience, container orchestration, they wanted to have we set a very high bar for the support for how we supported them on the PaaS side. So we wanted to, at least for the bulk of the workloads, give them a very similar experience, right? Out of the box load balancing, out of the box wildcard certificate, so they don't have to register their own. OS patching, infrastructure maintenance, persistent storage, and all the different flavors of that. One of the things that's a little more painful on the Cloud Foundry side is TCP ingress. So we wanted to give a service type load balancer. And most importantly, centralized logging and metrics. That's a big deal. And just the fact that if you can spin up your application and not have to write your logs to standard out and they go to the right place, that's incredibly powerful. And again, lets them focus on what they want to focus on, which is app development, not how do I log, how do I do log rotation, how do I make sure, all the data goes to the right places. From the hardware point of view, we again mirrored what we did for Cloud Foundry. Is we basically went with a shared nothing architecture where each column there is a single rack of hardware with top of rack network, compute, and storage. So there's no common elements between the three racks. Even the networks that go to the three racks are different. It's isolated behind a spine leaf so that our traffic never sees the core, only customer traffic in and out. It sees any other network elements, right? It's very high bandwidth, low latency, east-west. Region, the max capacity is about 55 terabytes of memory, 2200 cores, and 2 petabytes of storage. We could probably go bigger than that on a couple of these things. It's just a matter of cost efficiency in terms of DIMM size in the compute. So this was kind of a first guess at what we would need. We'll see, time will tell over the next couple of months. We deploy multiple of these regions to a single data center with the idea that there's production regions, there's non-production regions, and there's multiple production regions within a single data center so that teams can do a near deployment strategy. So even though we have multiple data centers and would like to be active across data centers, back to the data gravity, right? Most apps tend to run in one location. We wanted to make sure that they had an alternate to fail over to in case we had some sort of catastrophic failure within a region. So that's the point of the near-far deployment strategy. So on that hardware, right, what we wanted to get kind of established was what we call, and we stole this term from somebody else, is the Kubernetes dial tone, right? We want to be able to just provision clusters and get Kubernetes out of these regions with very low overhead and very, just press a button, get a cluster. Not quite there yet, but we're getting there. The product we chose, we ended up selling on was Pivotal Container Services. It's a framework that essentially is a service broker that deploys CFCR, Cloud Foundry, Container Runtime, BOSH service deployments. So it's basically a framework that manages your clusters. You have a set of plans, and then you choose which plan you want to use, choose how many nodes you want, press a button, deploy the cluster.
Yeah, it really is built around the concept of, you have your GKE or AKS, EKS on-premise, where you hit an API endpoint as an authenticated user, and you get a Kubernetes cluster spit back out. So we've worked with them a bit to determine what actually would make up that Kubernetes cluster, what it would look like, and what it means to get a cluster, and who we expect to be operating it as well.
Once a cluster is deployed, we have some more pipelines that kick in and basically demobilize the cluster. We install monitoring, persistent storage, ingress, load logging. It's still some manual steps to get the external load balancers configured. We're working on that. And then once that's, we consider the cluster production ready, do some Sonobuoy and other sort of conformance tests against it, and then say this is a live cluster. Then day 2 ops kicks in, right? Org and user management. We have a GitOps framework for our PaaS side. We're currently working on porting that over to the Kubernetes side, and then just daytime support. And support right now is onboarding customers, and it's back to the customer success engineering role, right? It's being we're being advocates for the platform. It's not the old days where we just say, here's your thing, use it. We are actively helping users develop good patterns. It helps us understand their workloads. It helps them understand our concerns as well. So it's been fantastic. We feel like we have a much better relationship with our customers now than we ever have.
Yeah, it's also not the old days of they can throw things over the fence at us and we just fix it for them. We make sure they understand that we'll give back the same level of effort that you guys give us. So if you say this is broken, fix it, we're going to say why is it broken. and make you troubleshoot your own problems. If you come to us and say, I've tried X, Y, Z, it's still not working, we'll help you figure out why it's not working. But it's not a situation where we can support all of our customers. On the PaaS side, we've got over 1,000 developers that operate on our platform. We can't handhold each one of those people. We need to teach them how to fish themselves so they're able to operate their own applications in their own platform without us having to do it for them.
So this was a healthy debate we had early on, is who owns clusters, right? And we're looking to provide, at least for the initial go around, a curated environment. We're not handing over clusters with cluster administrator access and they go to town, right? We are providing a resource. Customers come to us on board. We give them a namespace, right? That's the model that we are starting with. And it's the model that our customers are most comfortable with, or at least the majority of our customers are most comfortable with, and it's working out so far, right? At some point, we'll extend that to be, we know we have some more advanced customers or some more demanding customers that are looking to run their own cluster end to end. We're figuring out what that looks like. But for now, we manage the clusters, right, and then provide access to the teams, and they do their work, and if they need something, they ask us, and we do our best to help them with any problems they have. Multi-tenant clusters are an interesting thing. So one of the great things about PaaS is that within a single foundation, we just pack containers in like nobody's business. If we ran a bunch of independent clusters, right, there's a certain management plane overhead for each cluster, so we are completely have no idea what that would look like if every app started deploying their own clusters. So that's another reason for the multi-tenant clusters.
Yeah, at a minimum, we'd have 3 API servers and 3 worker nodes. So thinking about the amount of usage there, if they've got a simple, 128, 256 meg app that they want to run a few instances of, how much memory are we consuming to run that one app if they have their own dedicated cluster?
Early successes. So we have some live apps, and this is pretty cool. It's been a long time coming. The first app actually went live in August, and it's maps.tmobile.com. You can go to that on your phone. It's a coverage map where you put in a location, and it shows you T-Mobile coverage in that area. This is also a very cool example, because they are running in 3 or 4 different places and load balancing across them. So they're running in Kubernetes, in our on-prem Kubernetes. They're running in our on-prem PaaS, and they're running in the public cloud. I don't know if it's on Kubernetes or in the Meso stuff. It's okay, Kubernetes. Yep. So they have been one of our leading customers in terms of doing what we'd like all our customers to do, which is distribute your application to multiple places. So if you have a failure in one place, it keeps running. So it's a simpler app to do that with, but it's also a great pattern that we refer to other customers to. We also have some order management. We have our mobile point of sale systems that also connect to the Kubernetes clusters. Again, now that the primary part of the holiday season's over in terms of sales, they are now actively moving their workload onto our clusters. So it's very, very exciting to see what's going to happen there. We're already seeing a benefit from the seamless upgrades, right? Especially with PKS, where Pivotal provides a new version for us. We ingest it, run it through some staging clusters, and then push it to our production clusters. We seamlessly upgraded from 110 to 111. And another example of the success is the same day that the 111.5 patch was released for the API CVE, we were patched within 36 hours. And we've seen this back on the PaaS side as well, where usually our systems are patched far ahead of anyone else's systems because it is a single action to initiate a patch. And then one of the big things we look at for the Kubernetes platform is persistent storage. We've had fantastic success there. We've been very happy with our solution. It's in use by us. It's in use by our customers. We think this is going to be one of the critical capabilities offered by the platform. So we're looking to really build on that. Some challenges. TCP ingress. So one of the problems with running on-prem is that we don't have a service type load balancer out of the box. With PKS, you could install NSXT. We didn't. Lots of reasons there. Not going to go into them for too much here. But we're still looking at that, and we're evaluating some new solutions there. Right now, we have some workarounds. Essentially, a lot of node ports. Yeah, I don't like to share that.
Yeah, and it's kind of an example of how we've changed. We started out saying node port's not an option. We're not going to offer that to our customers. And then first customer says, I need this. And we say, well, yeah, you definitely need that. We can't really just say no and say you can't get this traffic in. Yep. So it's an example of a place where we haven't found a good solution yet for an automated TCP ingress. We keep on hoping all the various ingress flavors will give us an option, but currently it's mostly CRDs or the things like that we're looking for something a little bit more native, which we've seen from a few different hardware load balancer providers. So we're going to test out some of those options and see where it takes us.
Adoption's a little slow. It's Kubernetes. There's a very steep learning curve, right? So we're ramping up internally on that. We have a cloud native COE that's helping out to get our developers be more productive in Kubernetes and to help them, establish what are best patterns for the enterprise instead of everyone having to go do their own research. And then finally, PKS is great for some stuff. That still has some issues that we're looking for them to help us with. One of which is it's not as configurable as we'd like it to be. We can't use pod security policies. We can't use pod presets. So we are working around those. We are looking very hopefully to the day when that will be available out of the box. Quick. We're out of time. Lessons learned. So the lessons learned aren't just for Kubernetes. It's been for this whole 3-year exercise. And the first thing is own what you can. If we want to deliver quickly, just like we provide a platform to our customers to go faster, we have to go faster as well. So we've actually taken on extra load for infrastructure components that we would not traditionally own. We've had great management support to enable that. But in some cases where we don't own it, we have to form closer partnerships with teams that own our services and impart to them the importance of velocity and why they need to move so quickly with us. Limit blast radius. So we had one production foundation. We started losing sleep because if it went down, it was everything. So now we've learned from day one, tell your customers to provide your customers multiple places to deploy and tell them to deploy multiple places so that you don't end up with 80% of your workload in one place and 5% utilization everywhere else. Upgrade and patch often. And this is, we didn't do this and we let a couple of customers hold us back. And it was a huge mistake. And we spent, actually people in this room spent, a week straight upgrading some of our environments from one release to another to get caught up.
To another. It was like three or four decent sized releases for PaaS, all within about a week or so.
Yep. So our new mantra is like we do not inform our customer, or we inform our customers when we are going to upgrade. We don't ask them. We do a little bit of consulting. We know we don't want to do it on the busiest day of the year, but we essentially, when we're ready to patch, we run it through our staging environments and then we patch. We're working on having repaves happen automatically, just even if it's not needed, just to refresh the environments from time to time. That's good for us because that keeps our environments fresh. It's also good for our customers because it kind of helps them build the muscle of what a repave looks like and how they need to deal with it and how they need to look at it. And again, don't let individual apps, we're a shared platform now. We cannot let individual apps dictate the schedule for the entire environment. Set expiration dates. This is more on the Kubernetes side, right? We are telling our customers, you get this cluster now, but this cluster is likely going to go away at some point. So you need to build your tooling so that when we give you a new cluster, you can deploy there automatically. Encourage customers to be able to deploy to multiple targets, right? That enables that behavior. And what happens, and this kind of happened on the Cloud Foundry side, right? It's the primary foundation is it's become a pet, right? It's not cattle anymore. So we're trying to figure out how to avoid that on the Kubernetes side. Automate everything, yeah, that's of course. Another big thing. It's back to the non-technical requirements, but it's create a community for your customers, right? We created a Cloud Foundry channel. We have a Kubernetes channel now, and we already have in both places customers answering other customers' questions, which for us is absolutely fantastic, right? That's what we were hoping for and what we were looking for, but it takes the burden off of us. It makes everyone feel empowered, makes everyone feel valuable. You get immediate feedback. We're not on there all the time. It's been just a tremendous success. How many people do we have on the Cloud Foundry channel?
I think over 1,000 now.
Yeah, so Slack's been an absolutely fantastic tool for us in that space.
It's also a great way for us to notify our customers. We don't have to have some massive email distribution list that we email it to everyone that they're going to ignore. We just have at here or at channel saying, hey, we're doing this right now, or this issue is going on. Please be aware of it.
Yep. And our pipelines that do repaves and those kind of work actually post to the channel to notify customers when it's happening and when it's finished. And then on the horizon, we're really looking for Kubernetes. We're really looking forward to being able to provide hosted data services, not just that we provide, but that any team can provide. We have some on-prem data services teams that are looking to onboard to the platform so they can figure out how to move their customers from the existing legacy infrastructure onto more modern platforms. Service mesh is going to be a big thing for us. Knative is going to be a big thing for us. This has been an interesting recurring topic that I've seen here is should developers be using kubectl? Probably not. So what's the next thing that's going to be the abstraction layer that helps application developers and owners have a more PaaS-like experience on top of the CaaS platform? So to me, that's an amazing space that it looks like there's a lot of work going on in. So we're very much looking forward to what's coming out of everyone for that. Operators, and then cluster federation, right? How can we seamlessly run a single app in multiple clusters in multiple locations? And then it's kind of a high-level list of the tools we use. I've missed a couple, so I apologize. It's a lot of things, and it's back to it's hard to hire for this because what do we put in a job description? Hi, are you familiar with all these tools? And yeah, no one says yes. So. All right, I think we're a little over Q&A.
Yeah, I think we're over time. Thank you all.